Hi everyone, my name is Christian and this is a tutorial on how to do an analysis of a piston head on the Patran and Astron programs. So first we open the Patran here, we hold until it's wide open, and now the first thing that we need to do is to create a file, and we need to make sure to save it onto a specific folder, sorry, which is going to be tutorials in this case. You give it a name, in this case it's going to be piston, and you click OK. So the next thing to do is just to import the geometry that you're going to be analyzing. In this case, piston, and you click OK on this screen that's just open. We're going to use a smooth shaded view because it's cooler. And well, the first thing we need to do to analyze this piston is to put a mesh on it, right? So we're going to create a mesh. We go to meshing, create mesh, and solid. So input list, we choose the whole solid, and the global edge length recommended for this specific solid is of 0.25. But since I don't have the complete version, I mean, I have a limited scholar license of the Patran program, I can use this this global edge length for the mesh because it will be a very big or large mesh with a lot of nodes. So I'm just going to put a 2-unit value for the global edge length, and as you can see, it's going to be not a so big uh, mesh, but still it's going to be useful. So after we've made our mesh, we click on apply, and well, I've already made. So now the next step is to create the loads and displacement constraint that we're going to use. First, I'm going to start with creating a displacement that's going to be nodal, and in input data, I'm just going to fill the translations vector because I just wanted to be fixed in the translational sense. You need to put a name, and you need to select an application region, and the application regions, it's going to be the pinholes right here. So for you to make it easier, you can select here the surface selector, and I recommend you to go in a angle down, because if you try to do it this way, it's going to select, as you can see, the whole face. So I go here like this in a weird angle, and utilizing the key shift, I'm just going to select both pinholes surfaces. After I select them, just add it and click OK, then apply. Then we can visualize the translational displacement. Now I want to create pressure on the up the head of the piston. Pressure element uniform. We're gonna input data, and it's going to be a pressure of 1200 pascals, or any unit you want. And we're going to select the face, the upper face right here. We're gonna add it and click OK. Once we have our input and application regions, we apply it. Oh, sorry, you need to always put a name. So it's going to be just pressure. So that's it. The next step is to give it a dimension or a property to our piston in order to make it real. So we're going to create a material here in properties, isotropic, create an isotropic manual input, and our material is going to have 3 megapascals plastic metals and 0.3 Poisson ratio. You can input the 30 megapascals as 30e to the 6. Click OK. The material name is going to be steel, and that's going to be all. Now you can apply it, and you can see here that you have created the steel material. Now you're going to create and apply that material to the piston by going here in solid 3D properties, and input properties. You're going to select this square right here that says mat prop name and select your material steel. Okay. Now you're going to select the application region, and you're going to make sure that you select all of the solid. So you add it, click OK, and apply it. Again, you need to use a name, which this is going to be our piston or steel piston, and we apply. Now we've applied. We can see right here that we have. If you have questions, you can always go to here and see what's the last thing you did, and it looks successfully done. So we have created our constraints, our forces, our mesh. We have given a dimension to a real dimension to our piston geometry, and now we're ready to analyze it. For that, we're going to go to analysis, and just to make sure, let me check some things. Okay. Yeah, that will be all. Now you need to go here to loads and load cases. This is just to see if you have created successfully the displacements of pressure you want. As we can see here, we just have one displacement and one pressure, so we have successfully done it. And now we're ready to do the analysis of the entire model, and just make sure that the solution type is linear static. Once it is, you click on apply, and the program is going to send it to Astron. Astron is going to send you back after creating some archives, some files there. One of those files is going to be an XDV file, which is the one we're going to analyze and traduce into this Patran program. So we click on XDV, we select result files, and as you can see in the folder you first created your Patran file, you will have now your Piston XDV file. You just select it, click OK, and then apply. After doing so, you can see some results on your piston, which right now aren't so visible because of the weak mesh that I've created. Remember, I told you that I couldn't make a very big mesh, but actually there are some changes on this one, and for you to see it, you need to go here to results, and you'll see that. Sorry, if you go to display and you just plot erase, if we erase our first geometry, which is this one, and then we plot it, you can see that it changed a little. Like in this part, it's due to pressure, it's changing its geometry, but maybe it's not so visible because of the way we've done it. So we can move forward, and after erasing the geometry here in the plot erase, we go to results, sorry, and create a quick plot.